Welcome to AI for GIs, Introduction to Artificial Intelligence. Class 18, Building AI Agents with Agent Studio and Ask Sage. Workflows follow instructions. Agents make decisions. That distinction changes everything about how you design AI systems for your section. Today, you learn how to build agents that choose their own tools, route their own tasks, and know when to stop and ask a human. I'm Dr. Justin Webb. Let's begin. 5 objectives. Every one is a design skill you will use the moment you build your first agent. Distinguish workflows from agents. Master the 6 tool types in Agent Studio. Design an agent system prompt on paper. Understand how MCP makes your agent skills portable across platforms. And identify the 5 security controls required before any military agent goes live. That first objective is the foundation for everything else. A workflow is an SOP codified in software. Same input, same steps, same output every time. Supply request over 25,000, route to brigade commander. The logic never changes. An agent is a staff officer who knows the SOPs but decides which one to apply based on what walks through the door. 6 dimensions separate them, and the decision rule is simple. If you can draw the complete flowchart before the first request arrives, build a workflow. If the path changes depending on the input, build an agent. So what does this look like in a real staff section? 20 intelligence requests a day. 8 need database searches. 7 need open source research. 5 need doctrine lookups. With workflows, a human spends 3 minutes routing each request. That is 60 minutes daily on zero-value categorization. One agent with 3 tools eliminates that hour entirely. It reads the request, picks the tool, executes, and delivers for human review. The agent does not replace the analyst. It replaces the routing labor. Now the question is, how do you actually build one? 10 steps from creation to deployment, but they are not created equal. Steps 1 through 3 are administrative setup. Steps 8 through 10 are deployment and testing. Steps 4 through 7 are the engineering core: tools, model selection, system prompt, and temperature. That is where agent quality lives or dies. Spend your time there. And step 4, tools, is where it all starts. 6 tool types. Every capability your agent has comes from the tools you assign it. Action writes data. Object query reads data. Function computes. Command triggers other systems. Update app variable changes dashboard state. And request clarification asks the user a question before proceeding. That last one is the most critical for military applications. An agent that guesses when it encounters ambiguity is more dangerous than one that stops and asks. But knowing the tools is not enough. You need a framework for choosing between them. 6 scenarios, 6 answers. 1 rule to remember when you are unsure. Default to object query. Read-only is inherently safer. You can always add write capability later, after the agent proves reliable. You cannot undo a write action that should never have happened. Here is what a complete agent design looks like using these tools. Here is a real agent design. The Brigade S2 Research Assistant for 3rd Infantry Division. 3 tools: object query for database searches, function for threat assessment calculations, and request clarification for ambiguous requests. Notice what is missing. No action tool. This agent cannot modify the database. Read only by design. Claude 4.5 Sonnet at temperature 0.1, because intelligence work demands consistency, not creativity. That is Agent Studio. Ask Sage takes a different approach entirely. What happens when you ask basic Ask Sage about deploying a Stryker brigade to the Pacific in 90 days? You get a general overview. Deep Agent decomposes that into 6 subqueries: sea lift capacity, preposition stock, fuel consumption, maintenance supply chain, host nation agreements, and port throughput. It searches multiple sources simultaneously and synthesizes a structured briefing, 3 to 5 minutes versus 2 to 3 days with a 4-person logistics cell. And the reason Deep Agent can reach all those sources is one protocol. MCP is to AI agents what USB is to hardware. One standard protocol that connects any agent to any tool. Ask Sage uses it for SharePoint, GitHub, and custom databases. Agent Studio uses it. Claude Code uses it. Cursor IDE uses it. When evaluating any new AI tool, ask one question: does it support MCP? If yes, your integrations transfer. If no, you are locked into a vendor. One warning: MCP's technical ability to connect does not equal permission to connect. Classified endpoints require G6 authorization. MCP is just one of several advanced capabilities worth knowing. 4 features beyond Deep Agent worth knowing. Workbook for persistent team analysis across sessions. Code Canvas for writing and checking automation scripts. Prose Canvas for collaborative document editing. And Model Compare, which deserves special attention. It runs the same prompt across GPT-5, Claude 4.5, and Gemini 2.5 simultaneously. Remember Class 5. Benchmarks predict general capability, but only testing on your actual workload reveals which model wins. Model Compare makes that test trivial. Tools and platforms aside, your agent lives or dies on one thing. Your agent is only as good as its system prompt. 5 components, every one required. Persona: who is this agent? Capabilities: what tools can it use? Constraints: what must it never do? HIDL rules: when must it stop and ask a human? Output format: how should it present results? Most military agent designs fail at components 3 and 4. Designers specify what the agent should do, but forget to define what it must not do and when it must stop. And the next design choice directly shapes how those instructions play out. Temperature 0 means identical inputs produce identical outputs. Temperature 1 means maximum creative variation. 4 ranges, 4 use cases. The bottom line: most military agents should live at 0.1 or lower. Your S2 research assistant should produce the same analysis at 0800 that it produces at 1400. Save temperatures above 0.5 for red team exercises and training scenarios. The prompt and the temperature work together. Here is the strategic logic behind that pairing. 80% of your design time goes into the system prompt, 20% into model and temperature selection. A mediocre model with an excellent prompt outperforms an elite model with a vague one. But here is the critical warning: system prompts are not security barriers. A determined user can bypass prompt constraints through prompt injection. Real security comes from the platform permission model. The prompt governs normal behavior. The platform governs adversarial conditions. You need both. That is the capability. Here is the security architecture. 3 layers, all 3 required. Layer 1, platform security. You inherit this from your G6 and security manager. It controls who accesses the agent. Layer 2, agent permissions. You design this. It controls what the agent can do. Layer 3, system prompt constraints, also yours. It controls how the agent behaves. The common mistake is assuming layer 1 is enough. 3 different questions, 3 different answers. Skip any one and you have a gap. Layers are the architecture. Now here are the specific controls. 5 controls, 0 exceptions. Permission scoping so an E5 sees different results than an 06. Audit logging so you can reconstruct exactly what the agent did. A kill switch that disables the agent in minutes, not hours. HITL gates before any high consequence action. And testing before deployment, not after. No shortcuts for just a quick deployment. Quick deployments become slow incidents. One of those controls, permissions, deserves a closer look. A read-only agent that makes a mistake gives you a wrong answer. You catch it in review and move on. A read-write agent that makes a mistake changes real systems. It creates a supply request for 500 rounds when you needed 5,000. That error enters the pipeline and cascades. Start every agent read-only. Observe 50 to 100 interactions. Add write capability only after the agent proves reliable. Minimum viable permissions. Expand only with evidence. Permissions control the blast radius. 5 test categories. Not optional. Happy path. Does it work with normal input? Edge cases. Does it handle vague or incomplete requests? Security probes. Does it respect its constraints? Error recovery. Does it handle system failures without hallucinating? Load testing. Does it hold up under concurrent users? 3 test cases per category gives you 15 scenarios. Security test failures are deployment blockers, not improvement items. Here is exactly what those 15 scenarios look like for the S2 agent. 15 test scenarios for the S2 research agent. 3 known answer queries for Happy Path. Vague queries and misspellings for edge cases. Clearance violations and prompt extraction attempts for security probes. Timeouts and empty results for error recovery. And 10, 20, and 50 concurrent sessions for load. All 15 executed before any analyst touches the agent. Not after, before. But here's the part most teams get wrong. They test once and stop. Testing does not end at deployment. 4 triggers require retesting. Model update. When GPT-5 becomes GPT 5.2, the reasoning engine changes, and your agent may behave differently even though you change nothing. Prompt change, tool modification, and scheduled review on a monthly or quarterly cycle. 30 minutes running your regression suite prevents the consequences of an agent whose behavior has silently degraded. Those are the details. Here is the full picture. 6 principles. Workflows for the 80% that is predictable. Agents for the 20% that requires judgment. 6 tool types, with request clarification as the most critical. System prompts are standing orders. Spend 80% of design time there. MCP is the universal connector. Learn it once, apply it everywhere. Start every agent read-only with minimum viable permissions. And test 15 scenarios across 5 categories before deployment. Then retest after every change. The lesson has the full details on each. One more thing before we close. Next class, we connect Power Automate to the Ask Sage API. That is where enterprise orchestration meets AI reasoning, with confidence-based routing and token budgeting built in. Stay connected with AI for GIs on TikTok, Instagram, YouTube, and LinkedIn. Visit the full course at the link below. I'm Dr. Justin Webb. Thanks for joining me for AI for GIs.